This video covers the steps to conduct a dependent t-test. The dependent t-test is done when you want to compare two means of the same assessment on the same group observed at two different periods in time. So a pre-test compared to a post-test. The first thing you do is ensure that you have your columns prepared and ready to be considered in the dependent t-test. So in this case, we have a process test at time 1 and a process test at time 2. So a process test is typically a test of movement mechanics. Oftentimes we'll have fitness assessments that we give periodically throughout the semester or throughout a unit, and we want to determine if there's a significant improvement from one time to the next. The stipulation, though, in a dependent t-test is that you can only look at two different points in time in one analysis. So the first step is to go to Analyze, Compare Means, and go to the paired sample t-test, which is also known as the dependent t-test. You'll see paired sample t-test referred to in your textbook and in other writing about statistics. So click the paired sample t-test and you'll see that the process 1 and process 2 assessments are already in there, but what will happen is you will have a clear box and simply click on the process test or the first pre-test, and then the second time the test was administered, or the post-test in this case, and simply click OK. You'll be redirected to the output page like in previous statistical analyses that we've been covering. In this case, you'll see that the mean for 30 people at time 1 is 21.36 or 37 if you're rounding up to the second decimal place, with a fairly small standard deviation of 1.59. The same group of participants or students were observed at a second point in time, and you can see that their mean improved from 21 to 24.2 with a similar standard deviation, quite small. There's a paired sample correlation that is also provided in this analysis, but we are not interested in that at this time. What we are interested in, though, is the mean difference. So there was an improvement from time 1 to time 2 by an average of 2.83 points with a standard deviation of 2.21. And if we look over here, we'll notice the t-value and the degrees of freedom, which are to be noted. And the sig value, or also known as the probability of those differences being greater than what we'd expect from measurement error, or by chance, in other words, is actually significant. So we can conclude that from the pre-test to the post-test, the students in this class improved a significant amount, and the assumptions here are, for a practical standpoint at least, are that the teacher was doing his or her job, the students learned, the students improved in their ability to do the mechanical component of whatever the skill is. In this case, we were focusing on basketball. And the point of interest here would also be to share this information with students, with parents, and administrators, because this is a piece of that suggests that you are an accountable teacher and that your students were accountable learners.